So these are two problems that we'll look at, 120 and 377, right? These are the two things. 120 I feel we'll go first because many of you gave, like Saturday night is still possible. तो पहले ये कर लेते हैं. ये क्या था? This is the post contest discussion का, where nobody writes anything. Go through this. We'll go through all of this over here. Okay. Should take us fairly good amount of time to kind of go through all. So yesterday, like last session was mostly around 1 hour. This might go to 1.5. So I think that is an expectation to have. Okay, so we'll go through in order. We'll solve bi-weekly and then we'll go through the weekly wala contest so that all the questions are kind of covered and we have a good amount of ideas covered in all of them, right? So let's start. I think we are already at 4 marker. How many of you were able to solve? Can you give me the numbers that you were able to solve in today's weekly wala contest? I got that 2 questions is where people were able to solve today. 3. Okay, nice. 3 is pretty good. I mean, from what I expect people to know at is ki first 2 question ho gaye question contest ke, you have solved the first 2 problem. First 1 and 2, either 2 problems and then 2 more are left. So I personally feel that when you are giving Leetcode weekly, the first problems are easy, and in fact they are easy at a level where you can actually solve it with GPT-4, right? I mean, if I just paste this code to GPT-4, it will be able to solve the problem in just like 10 seconds. And that's why I feel like the weightage of first problems has been decreasing over time. People are able to solve it in less than 1 minute, which it even takes to read the problem, right? So let's go through the bi-weekly wala part, right? So the bi-weekly contest starts with this problem where we have to count the incremovable subarray 1. So incremovable subarray 1, there is a version 2 of this. So what we'll do is we'll solve these 2 together and then we will look at this polygon wala problem and then we'll look at this tree wala problem, right? In this minimum number game, square fence, minimum cost 1, 2. Okay, so there is again 2 versions. So which means we have to solve technically 6 problems, right? So let's start with the first problem. Count the number of incremovable subarrays 1. Count the number of incremovable subarray 1s, which says that strictly increases on removing the subarray. For example, the subarray is incremovable, incremental and removable after removing the subarray, because after removing that you get a strictly increasing. What's the constraint? 50. Very obvious solution. For every loop through all subarrays, delete it and check whether the array is increasing or not. Everybody agrees that this is what we will use to solve this problem. Quick +1. Very simple version. The simple version is super simple because it's 50. So what the idea would be that we go through all subarrays, because the number of subarrays is order n square, quote unquote, right? N into n plus 1 by 2, obviously. So you go through all subarrays, delete that subarray and see if the leftover array, it takes O of n to build that leftover subarray. You can check whether that is incremental array or not. So after deleting it, you can build the new array and check is it increasing or not. O of n check. So n cube subarray, for every subarray you have to do O of n iteration to build that array and then again O of n to check if it's increasing. So n cube, we can solve this problem and it will pass in 50 for sure, I think, right? Can I have a quick +1? I don't think we need to code this. Why is this Rust? Oh, I remember in the last session I coded one problem in Rust. No, I mean using GPT, obviously. So this is straight away just doing whatever is asked, right? So this is easy. The harder bit I think would be the second version. I was expecting this 10 to the power 5. Super expected कि भाई ऐसे questions तो array वाले, in array problems you generally get 10 to the power 5 problems, right? So I think question is the same, just the constraints have increased and the number values are 10 to the power 9 and subarray length is 10 to the power 5. So how would you think about it? I think this is a problem that calls for kind of drawing few things and looking at values, right? Okay. So let's take an array over here. Okay. The first thing that you should do in such problems whenever you see these is think about the operation first. कि क्या बोला गया? What is exactly being asked? That you have to choose a subarray and delete it. So there will be some subarray which will be chosen and will be deleted. So this portion should be increasing and this portion should be increasing, and then this element should be less than this, right? I mean, so that this, after removing it, the whole thing is like this, right? First of all, is this visualization clear to everyone or not? Unless you are able to visualize this, there is no way you can solve this problem. Ki there is this subarray being deleted, so this part needs to be increasing, this part needs to be increasing, and then there has to be a direct movement from here to here. Is this part clear to all of you? Quick +1. I will go step by step. Like, it's not about solving this problem. We have to think about how to think about such problems. Okay. Okay. Now let's look at one example, like 1, 2, 3, it's increasing. Then some weird things happen, like 2, -3. Is negative numbers allowed by any chance? I think no. But some weird things happen here. And then maybe 2, 4, 6, something like this. Okay. Let's say this is the set of values that is given to you. Like, this is the array. I've just made it in an like a hill kind of an order, because we have to think it in terms of that, right? It is not about like just values, right? The increasing and decreasing trends do matter. Okay. So now let's try to think about from the end. I mean, this is increasing, this is increasing, this is increasing. So everything is fine till then. Now this is decreasing. The first time you see a decrease, you have to realize that as soon as you see a decrease, the subarray can, the deleting subarray can never end before it. Because if you end before this, the deleting subarray that has to be chosen, right? This deleting subarray that has to be chosen. If you end before this, like some portion you are deleting over here, this increasing trend in this part will not be followed. Is this part making sense to everyone? That if the deleting subarray that you have to choose ends before this breaking pattern, I mean, the pattern, the decrease that is happening over here, then, or maybe on even on this side, either side, right? This can never make this increasing at all, right? I mean, no matter what you choose, even if you have 1, it is increasing, but then there is a decrease always there, right? Even if you decrease these two numbers. So 1, 2, 3, 2, 1, 2, 4, 6. The decrease has to be over here. The delete that has to be there has to be over here or after this. Is this part making sense to all of you? That decrease का choices तो यही है मेरे पास. This is the only choices that we have for decreasing the deleting subarray. If you have to make it increasing in order, that you have to delete either over here or over here or over here or over here, because the suffix over there is increasing. Firstly, everybody clear this till this point? Okay, great. So this is the first observation. This is the main observation of this problem. If you can get this observation, you should be able to solve this problem. Okay. The first thing that you have to realize is there is this diagram. Then you realize that you have only finite number of choices at the end, which needs to be the ending point of the deleting subarray. And very similarly, you will see that, okay, there is a increase, decrease. So this decrease needs to be deleted too. So the starting point should be before this as well. So the starting point choices are over here, deleting subarray ka. You can choose to delete from starting over here, and you can choose to delete till at these points. Is the question manipulation till this point clear to everyone? That no matter what kind of graph you have, the values increasing, decreasing, 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 ऐसे कुछ, you will see that you will have to delete this portion for sure, क्योंकि ये रहेगा, कुछ भी रहेगा इनमें से, so you can never make it increasing ever again in the process that is given to you. So this is what you are looking at, that this wavy thing needs to be deleted. So you have a finite number of choices at the start from where you will start deleting, and then there are finite number of choices where you can end deleting this. This is in fact the main observation of this problem. How many of you are clear till this point? Next is just simple. I think mind research should be enough to do this rest part. Okay. So now you realize that, okay, there are some starting points and some ending points. There are starting points and ending points. And if you see the way they are arranged, the starting points are like over here, 1, 2, 3, like this is the starting point of deletion. So 1, 2, 3. Okay, this is the starting point of deletions. And then the ending points are over here. So ending point 1, ending point 2, ending point 4, ending point 6, right? This is how the things are going to look on two sides. So we can build two arrays. One is the suffix wala decreasing array, and then suffix wala increasing array, and that's prefix wala increasing array. These two parts we can build separately. Now we have to match ki, acha, for which all options are available. Like if I delete from over here till over here, then this 3 will be followed by this 1, which is not valid. So if I want to choose this starting deleting over here, then the number before it is 3. So till whichever point we will delete, the number after that should be greater than 3. That's all you have to find out. That, hey, if I choose to delete after this 3, then the point where I will, till which I will delete, the number after that should be more than 3. So that I can simply search by using binary search, that, hey, what is the first point, which is like, I can iterate through these numbers, I can choose 3 and see, acha, I will start deleting after this. So find the suitable point in this sorted array where it's bigger than 3. You will find out this 4. So you can delete over here, you can delete over here, you can delete over here. So you can find 1, 2, 3, right? So you can find 3 choices for this number, like this starting point. Then for this, the starting point is 2. You will look at in the problem, is it strictly increasing or decreasing? Strictly increasing. So for 2 also, the point beyond which you can start taking is 4 and 6, because if you delete till this much, 2 will be, you start over here and you delete till this much, 2 will be followed by a 2, which is not valid. So you will again do a like upper bound, quote unquote upper bound, you'll have to use in this problem to find this point where the element is just bigger than 2. And then you can find out, okay, you found out the point, the number of valid positions is just before it, just before this, and the end one also. So 3 again. Plus for this 1, you are deleting over here, you will choose which point to delete to. So 1 can even delete, if you delete till this point, 1 will be followed by 2. So this will be 1, 2, 3, 4 plus 4. Plus you can delete over here also, which has nothing over here, which means you can technically take anything over here. So all the points will be valid. So 1, 2, 3, 4, 5. Just calculate this number. This will, I think, come out to 15. 15, right? Yes. And that's how you can solve this problem. Is the idea making sense now? How you could have thought about this problem? Quick +1 if the idea is making some sense. Great. That's a good signal. If you are able to understand this, then most probably it's more about just thinking these ideas in context. You should be able to code this also. This is not super hard, no? Like increasing array, make it a new vector, decreasing array, make it a new vector, just do upper bounds and stuff. You would be able to do this. That's not a hard thing. The only thing would be to kind of come up with this logic in the context. And there is a very incremental process for that, isn't it? If you think about it, see this, see this, see this. That's it. 3-step process. I mean, I sometimes feel Leetcode makes it problem number 2, problem number 1, problem 2, 3, 4, based on how many things you need, how many layers of thinking you do need in this problem. 2 or 3 generally for the third problem, 3 or 4 for the fourth problem, or some standard idea. Right? So that is basically how you solve this particular problem. Done? Move to the next one. Quick +1, if we can move to the next one. So this is hard, nice. This is a good problem. Chalo. If we need, we can look at code at the very end. I think you all would be able to do this without even looking at my code. I mean, this is much more doable. If required, we might look at other harder problems. You are given a positive numbers of n. A polygon is a closed figure which has at least 3 sides. The longest side of polygon is smaller than the sum of its all other sides. Right? Okay. So conversely, if you have k, this is polygon with k sides. Correct. This makes sense. So perimeter of a polygon is sum of length of its sides. Okay. Nice, makes sense. Return the largest possible perimeter of a polygon whose sum of sides can be formed from nubs. Okay, this looks. So basically, you will have to just check that whether the set of smaller elements is able to make the sum till that point or not. Chalo. So this is, I think, sorting, direct sorting problem. No. So the idea over here is, where did we go? If you have bunch of numbers, first of all, the cost or the thing to optimize is sum of lengths, which is nothing but the sum that we are taking right now, right? So bunch of numbers, they can be arranged in any possible way, sorting possible. You have to make sure that the sum of the smaller elements, like if you are taking 10 numbers, the sum of the smaller 9 elements is bigger than the sum of the last element alone. That's all you need to check. Okay. How do you do that? And we want to take as many elements as possible because that will make our perimeter largest possible. So just simply maintain bunch of elements. And so for obviously we'll take the smallest elements because they are cheap to take. If you take till I, there's sum you can find using prefix sum till I. And for any new element, you can check, can you take this into the subarray, into the, with this I plus 1 element, can you build a polygon? It is only possible if you take this element as the largest side, since it's sorted, and the rest of them will just be used to join the other ends. So if the prefix sum till I is bigger than the element at I plus 1, then you can make this all together into a polygon. Does this make sense to everyone? If you 1, 1, 2, 3, 10, if the prefix sum till this point is bigger than this, then this whole can make a polygon. 3 followed by 1, 1, 2, something like this, right? But then prefix sum till this is not bigger than this, so you cannot make a polygon out of this. So you can just simply check till this much, the sum is 3 plus 7, this is 10. So if you keep a 10, no matter if you put everything like this even straight, you will reach till 7 only. Clear till this point that you have just this 7 over here and you cannot make it. Then again, if it's 20 over here, you can take all of them and then like if it's 11 over here, then if you take all of them and then try to make this 11 and use this to make it covered, yes, you can do it because this sum is bigger than this. So this whole can be taken together, right? So it will always be a prefix somehow, and then you can check all prefixes quickly using prefix sums. Clear, everyone? I mean, not even prefix sum, you can just iterate and do it if you want. Okay, that can I use the first few elements to build a polygon? The check is this should be smaller than sum of these elements. That's it. You can use prefix sum, you can use running sum, all these things can be done. Clear, everyone? This is how exactly you look at this particular thing. समझ में आ गया ये? Easy? Easy peasy? No, not easy. Easy तो नहीं है, but it's a good observation. I mean, when you see 10 to the power 5 k number of sides you have to choose, right? It's not, it's obvious that there will be something greedy in this, like kuch to sorting hoga, because no other way is possible that you can choose k elements out of things, right? Neither DP nor anything is possible. So generally these problems move to greedy itself. Okay. So this is another problem solved. We have the hardest problem I think left. So let's look at this also. I have not seen this problem yet. So you're given an undirected tree, n nodes, 1 to n, rooted at 0. Your 2D integer array, edges of length is, okay. So there is a tree given to you with edge given to you. 0 indexed array, cost. So every node has some cost. You need to place some coins on every node of the tree. You need to place some coins on every node of the tree. The number of coins to be placed at I can be calculated as, if the size of subtree of node I is greater than 3, place one coin. Otherwise, place the amount of coins equal to maximum product of cost value assigned to 3 distinct nodes in the subtree of. If it's less than 3, then place one coin. Okay. So maximum product of cost value assigned to 3 distinct nodes in the subtree of I. If this product is negative, place 0 coins. Okay. Which topic is this? I mean, it's fixed, like the answer is fixed. Return coins of I. There is no optimization that you need to do, except obviously like it's fixed that you have to choose the 3 distinct maximum product wala nodes. There is no like optimization problem. It's just find the values, right? That's the question. So you have to place, there is a rule given to you. You have to just simulate this process, right? Maximum value, maximum product of cost values assigned to 3 distinct, maximum product of cost values assigned to 3 distinct nodes in the subtree. Okay. But there are negatives possible. That is what makes it more interesting, which I can understand why they have made it there. Okay. Okay. So if I have to think about this problem, how will I go about thinking such problems? Okay. Let me give you my thought process. First of all, is the picture clear? There is a tree with each node having some value, and then there is a rule that on each coin, in each node, you have to place some coins depending on this rule. Right? ये पहले clear है सबको? Is this clear to everyone? It's a rooted tree given to you with some rules, and you have to just, you are given some values at each node. You have to decide based on that. Okay. Next, when I see this problem, I immediately start to see ki, acha, if it's so simple, why are we not able to do it just by looping through or just doing a DFS? Two caveats. Number one, you have to find 3 distinct nodes whose maximum product of cost values will be found, and that is what you want to assign there. And then there is a possibility of negative. So as soon as you read this problem, your mind should start alerting you that there are 2 possibilities that needs to be handled very well. One is, how do I find maximum 3 product, the product of 3 which gets me to the maximum? And then the second next thing is, the product might be negative, so how do I handle that? Like there are negative numbers that I need to handle. How do I handle that? That's it. That's all you need to understand for this problem. Okay. Now, when you have such a complicated logic, ki acha ye product of 3 nikalna hai and stuff, and there is this, I start to go back and not think about finding about every node. Pehle ek node to nikal le. Let's think about one node, and then we will think about every node, maybe, right? Okay. So let's focus on just one node. Let's say some node number I. Okay. There are bunch of subtrees. Obviously, if it violates the first condition, then like if this is the condition, the size is less than 3, then you place one coin. Those are obvious things. But then let's suppose there is an I node and there are bunch of subtrees. Let's say there are 3 subtrees. Okay. And you have to choose 3 nodes in the subtrees such that the product is maximum. So how can that happen? Right? In this subtree, you need to find 3 nodes, including that node. Subtree means including that node, I feel, right? Yeah, including that node. I think so. We'll check that anyways. I'll assume that we have to take that node also in the subtree. So for the ith node, you have to realize that we have to find 3 best nodes that can product and give us the maximum. Now, A into B into C is as max as possible. How can that happen? Obviously, we want to make it positive. So in that case, we will try to get either all positives or 2 negatives and then a positive. But then it might be that we don't have that many positives or negatives. So it can get negative also. So the best way to think about it is, number 1, find best positive. Number 2, find least negative. if we can do these things, then are we sorted? Yes or no? Matlab, either it will be positive, then we will try to maximize the number. And if it is negative, we will try to, matlab, in an absolute value sense, we will try to minimize the number. Does that make sense to all of you? Right? Great. So that's pretty much the idea that we'll use. Okay. How do I use this idea? One simple thing that I can think of is maybe I need to get something from these subtrees so that I can merge their values and find the answer. This is a very standard tree idea, that whenever you have to build an answer for a node, you get something from DFS using the subtrees, and you merge those values to calculate the value at that node. This is a very standard tree idea, right? So what do we get from the subtrees so that we can calculate the answer for this? So we need 3 values. So maybe all the 3 values come from the same subtree. So for each subtree, we need to get at least the 3 best, some best, okay? 3 best values, possibilities, okay? Okay. So 3 best possibilities is what might be required from each subtree. If I would have to implement this problem, I would have thought about, acha, I don't think here negative, positive, there are so much of complications that might pop up. What I will try to do is generate some potential nodes which are feasible from this, which are best in its sense, some best from this sense, some best, and then try to merge these sets. Here, how do we choose final 3 which will be the best, right? How do we do that? The way I would do it is, I will choose from each subtree. I will break it into 2 parts, positive, negative. Get me 3 largest, 3 smallest. I will not even need 3, but I'll still choose. In negative, 3 largest, 3 smallest. How many numbers are we choosing out of this? 3, 3, 6, 3, 3, 6, 12. 12 from each node, and then we'll merge all the subtrees. That is the best way I'm thinking about it right now. Here, कुछ नहीं समझ में आ रहा है मुझे. Best pair, negative, positive, कौन सा बनाएगा? I don't care about it. Just get me the largest 3, smallest 3, largest 3, smallest 3. Out of these only, like out of these numbers that we get from this subtree and this subtree and this subtree and this, something will get, the top 3s will kind of merge and give me the best idea, right? Best solution. So what I need to get in this whole subtree is positive largest 3, negative largest 3, positive smallest 3, negative smallest 3. ठीक है? Positive smallest 3, negative largest 3, negative largest 3, smallest 3. So that is what we will save in DFS. We will try to find out what is the smallest 3 values, positive values, largest 3 positive values, largest 3 negative values, smallest 3 negative values, and we will return in them. Okay? Why smallest positive? Why positive, smallest, and largest negative? Because what if the value is negative? What if the value is negative? So in that case, I want to, so let's say I know that I can only get, acha, if there are positive, if there are 3 positives, then we never will need this. Makes sense. I mean, that's a fairly good optimization. It might be the case, no? There is only 2 positive, 1 and 2, and then there is only 1 negative. So you want to get the smallest 2 positive numbers. But then if there are more positive, then you anyways will get this. So you don't always want to make this 3. Yeah, it makes sense. Okay, this is also possible. You can do it. So just to be safe, you can do all of them, but then you can do some optimizations. You might not need all the positive smallest and negative largest minus threes, right? You can just build with the rest of the things. And if you can get three largest positive values, then you always have positive solutions, no? I mean, then the negative will never happen. So you can optimize in that. But then it never hurts. Just to be safe, I will get 12 best thing from over here, then 12 best and merge it in the 12 best over here, and then again small, like get the best 12 out of it, then 12 best out of this and merge it in this same thing. So finally I will, for the whole subtree, get the smallest three, largest three negative, smallest three negative, and then out of them only some three combination will be there, so I can get best out of it. I mean, if the positives exists at a quantity of 3, then we will always have positives, so you don't even need to check them. So you can optimize based on that. But then the idea is the main thing. The idea which you have to kind of realize in this problem is, यार यहाँ से मुझे कुछ तो भी top 3 चाहिए पॉजिटिव नेगेटिव में, इधर भी कुछ टॉप 3 चाहिए नेगेटिव पॉजिटिव में, इधर भी टॉप 3 चाहिए नेगेटिव पॉजिटिव में, एंड देन यू मर्ज दीज वैल्यूज इन दिस नोड एंड देन you build the answer for this node. And you can build these things incrementally, like you will build the 12 values over here, and the 12 relevant values will only go up. The 12 relevant values will only go up, max to max. I'm just saying 12 भी नहीं चाहिए, 6 ही चाहिए. I think 6 values will be more than sufficient, I feel. Okay, top 3, I think best 3 absolute value. Yeah, best 3 absolute value will also work, I feel. Yeah, best 3 absolute value will always work, because either there will be two, if there are two negatives, there can be two negative, one negative, or zero negative. Okay, rest will be positive. So if there are two negatives, they can combine together to become a positive, and then we will choose one of the best positives, and then there can be three negatives. Yeah, 6 absolute value will be sufficient. कि 3 नेगेटिव है तो एक पॉजिटिव चाहिए मेरे को कहीं से, तीनों नेगेटिव है तो I will need the smallest 3 negatives values, no? If all values are negative, then I will need the smallest 3 negative values. But then if there are two negatives, then I will need the largest two values. So I think I will put 12 only. इतना सोचना ही नहीं है. If you are getting confused कि यार क्या होगा, इतने सारे केस वर्क करने पड़ेंगे, no need. Let the code handle it. You just build whatever will be relevant, rest all code will handle. कि भाई इधर से 12 वैल्यू जाएंगे, स्मॉलेस्ट लार्जेस्ट सब भेज दूंगा मैं, ठीक है, वो सब इधर आकर के मर्ज हो जाएंगे, एंड देन आई विल जस्ट लूप थ्रू 12 क्यूब मैक्स टू मैक्स, उससे बदल नहीं, उतना भी नहीं लगेगा. Then split the positive negatives and choose based on that, and that should be enough. Okay, so this is the strategy that you can use for this problem. I'm gonna read the problem once more just to check if the constraints are fine for this. Yeah, this is fine enough. Length, 2 values. Okay, so this is exactly what you can do to solve this problem. I mean, this will be, you might think that, okay, maybe the best 3, largest 3, and all these kind of cases you will handle on your own. Okay, but then you might miss something in an actual test and you don't want to do that, no? So it's better to kind of just push these values, and later on you can try and optimize कि अच्छा ठीक है, अगर 12 में ज़्यादा लग जा रहा है तो then you can remove some values कि अच्छा if there are 2 negatives then I will just, if there are 3 positives then just only send positives and negatives, big negatives, that's it, and stuff like that. You can do that optimization later on if you required. So just send everything. If there are less than 12 subnodes, then send everything. 12 values ऊपर merge करेंगे, right? So every node will merge 12 values in its parent set somehow. Set बोल दो या set नहीं, multi-set or vector basically. It will merge 12 values in there. So that is quick enough. Multi-set ही बोल दो, because we want to maintain largest, smallest and stuff. So we'll maintain 12 values only. 3 in each set. 4 sets will be there, 3 sets in each. Okay, so this is something that we can use for this problem. This kind of idea is easier to code. We can optimize this further, but then I don't think we need it at this point in time. Just pass 12 values, that should be enough. Okay. समझ में आ गया? Yes, at the end I will code this if required. ठीक है? Yes. Let's go through all the problems. At the end I will code this problem. This looks interesting, so I'll code this. Okay. ठीक है? 70% idea clear to all of you कि कुछ तो भी ऊपर भेज रहे values and merge कर रहे हैं. Is that clear to all? I know 100% will not be clear unless you see the code for this problem. So maybe we will code this problem. Okay. Great. That seems nice. Let's move to the next problem then. And with that, I think we are done with yesterday's contest. I'll leave this over here because we might want to come back and code this problem. So let's move to today's contest. I don't know how many of you have given this contest, but then let's quickly go through its problems. You are given 0 index array, nums, even length, and so it doesn't. There is also there is an empty array ARR. Alice and Bob decide to play a game where each round Alice and Bob will do one move. The rule of game is as follows: each round Alice will remove the minimum element from nums, and then Bob does the same. Now first Bob will append the removed element at the array, and then Alice does the same. Oh, sort and then pairwise swap. Huh? कुछ code versus vibe नहीं है. This is diff to A maybe. So basically you have to sort and then I and I plus 1 you have to swap. मतलब 2 करके swap कर देना है बस और कुछ नहीं करना. So basically what is happening over here, let's go through the process. An array in which first X will pick the minimum. कोई minimum जहां भी होगा उठा लेगा. Then Y will pick the next minimum. Then Y will put first and then X will put it in the final array. Then again the next minimum. So minimum so if you sort this array, you know which elements will be picked in that order itself. But then the first person will pick this. Then second element will pick this. We will swap these two and that will be the output array. So it's like just sort the array and then swap pair by pair. मतलब first and second will swap, third and fourth will swap and so on. Okay, this is what will happen. So this is fairly straightforward. Start with fourth one. Let's do it in order because it will not take a lot of time. So let's quickly move through them. I don't think we'll spend too much time, but then like if I start with 4, then it might be difficult for somebody who wants to know the third. No, let's do it in order only. There is a large rectangle n cross m rectangular field. One is this fence, fence. This is fence. So fences are given, and vertical fences are given. Ah, nice. So you basically, I think this is also, how many of you were able to solve this problem? Quick +1. This is similar to that one problem in AZ, no? Just with these grids are inserted one by one. You have to find the largest rectangle that gets formed at any point in time, right? Exactly, Shubham, correct. What was the problem name? Kuch hai kya yaad? I forgot the name. It's there in 101. Where is this rectangle wala thing? Okay. This is exactly the same, like exactly the same idea. If you have solved that problem, this is straight away simple. Shubham, if you remember that problem, very helpful if you can search me up. So I'll refer to that idea because that is a good follow-up problem for anybody who has not solved it. Okay, so this is exactly what you need to do, and we can remove fences from over here. So when we need to make it a square, the X difference and the Y difference needs to be same. Straight away, that's the idea. And then you can think about it in the terms of ki, acha, these are these fences, but you can delete. So any two pairs you can kind of take as the vertical two grounds, and any two horizontal grids you can take as the horizontal two strides, and in between them you will build a rectangle. In this case, no matter what you remove, you cannot make equal gaps in both of them. So what we want to do is we want to make equal gaps in both of them. Let's move to the drawing pad once. So I'm not putting the numbers x1, x2, x3, x0, x4, y0, y1, y2, y3, y4. So if I want to make a square, it can be between any two y's like this and then any two x like this, right? So what I need to check is, can I make the gap between two x's and two y's same? So simply I can put a map. I can make a map which contains all, or set also. You can use a set as well. So you will do all possible difference. Ki acha, y1 minus y0, y2 minus y0, like between this, between this, between this, then between this, between this, between this. All possible two pairs, you can make a gap between them, and that is a possible length of the width. Sorry, the height, width, right? The width. Any two gap between the y-axis will be a possible width. And similarly, any two gaps between the x's will be a possible height. So you can put the widths in a single map, that not even a map, a set should be fine. These are the widths possible. On the height side also, you can create another set and you can do n square operations. From 0, you can make it till this, till this, till this, till this, then from this, this, and so on. You can make n square different number of elements. And then any element that is common between them, you can use, like it's possible to make that length x and that length y also, same length, x equal to y. So that means we will have a square. So you can use those two elements and then simply say ki, this is a possible square. So you can go through one of the sets, check if it is present in the other. If it is, then x square is a possible answer. Do this for all answers and you should be good to go for this problem. Okay, straightforward. All pair differences will give you the lengths. Make two sets for the vertical and the horizontal side. If any two value match, you are good to go and you can use it as a square. If none of them match, you have a -1 answer. Clear, everyone? So this is a good idea. There is this follow-up problem which I'll suggest you all to do is like there is like incrementally fences being added. Find the largest rectangle that is there at any point in time in between the fences. Okay. So that's also like a follow-up of this, which requires set and some good manipulation around it. So you are given, so this is the one version. What is the difference between 1 and 2? Can somebody quickly tell me if it is there? Somebody, can you share the follow-up? Let me see. One needs to cost of conversion of string to other. Acha, acha, okay, okay. Oh, acha, okay, okay, okay. Got it. Let me read this problem real quick. I don't have that problem. I think it is there in AZ in AlgoZenith site if you have that access, but then for now I don't have that link. You can search it if you have solved it already. It is there, I feel. Vertical cut, it's there in STL section. Minimum cost to convert string I, 1. So source and target, both n length, you have this. Cost of I represents cost of changing the character I to character changed. So there is a matrix given. You are given a 2 0 indexed. Achha, okay, so there are certain relations given to you. Ki character I to character J, the cost is something. You start with this source string. You can pick any character X from the string and change it to character Y at the cost of Z. If there are is any Z, so that. Nice question. Nice. So over here, we will basically get a graph, if I think about it, right? It's a graph problem. Just give me like just one quick question, one minute, right? Back to back 2 calls from my family. Just give me one. Read the first and second part, both of it. I will solve it real quick. Just give me like 1 minute, right? Project power. Largest rectangle. Thanks, Devansh. This one problem, if you are, can use it. Arey yaar. This is exactly like more and more heights and widths are getting inserted. नहीं, largest rectangle ये तुमने कौन सा भेजा है? गलत लिंक भेजा है भाई. ये हिस्टोग्राम वाला है यार, ये नहीं. I have to search. ठीक है, इसको छोड़ो. Read the other problem. 2 वाला पढ़ो, 1 and 2 पढ़ो. I'll just give me like 1 minute. ठीक है. So this was a very similar problem that there has to be cuts that has to be made, and uh, like you have to find out after every cut being made on the paper what is the largest rectangle present. So same idea, sets में like जो gaps है उसको maintain करना पड़ेगा. That's exactly the same idea. ठीक है. Then anyways we'll move back. Like this is a good follow-up problem to think about कि how to solve this. ठीक है, इसको कैसे solve करोगे? Yeah, week 4 में, yes, this is a week 4 problem. Think about this. क्या ideas use करोगे इसके लिए? In 1 minute I'll just go and give a quick instruction. Floyd Warshall, correct. कैसे? Yes, sorry for the interruption. चलो, I'm back now. घर पे कभी कभी थोड़ा कॉल आ जाता है, कुछ कुछ चीजें पेमेंट करना है, ये करना है, वो करना है, तो करना पड़ता है ना बीच में. A bunch of responsibilities that you cannot avoid. चलो, source target, you have to make the characters change from this to this. So you know, right? So this is basically a shortest problem, shortest path problem, that you have to convert this character to this character, but you might not choose to do it directly. You might choose to do it through some other characters, right? That you can convert. So there is a edges given between in this graph. A to B conversion costs 5, then A to C might cost 3, and then C to B might cost 1. So you might want to convert A to B. The first string contains A, next string contains B. To convert A to B, you might go through this path to pay 3 cost and then 1 cost, right? So that will be super simple to kind of handle directly, and you can convert it in that way, right? In one operation, you can pick, sorry, this is the second part. No, sorry. In one operation, you can pick a character X from the string and change it to character Y. Huh. If there exists any index such that this. So changing one particular index, you need to find the cost and you have to find the total cost. So for every index, we know the source, we know the target. By default, you have the graph and the edges. What is the cost to convert this character into this character? So you can build this graph, run of ASAP, all APSP, all pair shortest path, which is Floyd-Warshall, to get the shortest path between every character to every character. And then you can see how to convert this character into this character. You have that value in the matrix. If it's infinity, you cannot convert it. If it is like some finite value, then you will be able to convert it and you can return that value. Sum of that for all indexes will be the answer. Is the first part clear to everyone? This is like you need to know the graph wala property. This is a standard problem of graph. This cost of character conversion is a very standard Floyd-Warshall application. There are 3 main Floyd-Warshall applications that I've seen in contests. One is, the easiest of them is direct Floyd-Warshall. The next one is this, some intermediate nodes जिसमें all pair shortest path solve करना है. And the third one is reindexing idea, right? That these 3 problems are only there that exist in Floyd-Warshall. इसके बाहर तुम्हें कोई क्वेश्चन पूछा ही नहीं जाएगा, right? Reindexing is like a hard idea. मतलब Floyd-Warshall builds incremental shortest path solutions. So it's on top of that. It's a Codeforces DIE problem, if I remember it correctly. I don't remember the problem name. Problem I don't remember, but mostly 3 ideas exist in Floyd-Warshall. So ज़्यादा कुछ नहीं पूछेगा तुम्हें कभी भी. But then I think let's move to the second one. Given 2 0 indexed strings, source and target, both of them of length n and consisting of lowercase this, original this. Okay? This graph is still same. You start with source. You can pick any substring x from x and change it to y at the cost of z. If any substring x and change it to y at the cost of z. Yeah. अच्छा, strings दे रखा है. अच्छा, so you have strings that are present. So string to string cost is given now, and then you can convert a substring into another substring. अच्छा, okay, I get it now. Have I read the problem correctly? इस string से इस string को convert करने का cost ये सब दे रखा है. From this, I can choose a subarray and convert it to the other corresponding part. I have to make from this to this. Is that the problem? Yes or no? Yes, right. Original of I is not equal to original of j. Okay, it's always changed. Nice problem. This was actually important. इसके बिना it's super hard to solve. Okay. This is basically saying, okay, now I've got the clear picture. So basically there is a string and you can choose a substring and convert it to the other counterpart. Like there is, if you can convert ABC to EFG. So if over here ABC is present, you can at X cost convert it to EFG in the string. But there is another condition that is given to you. Okay. The other condition is that if you choose this, next time you cannot choose something like this. मतलब ये choose नहीं कर सकते. The chosen subarray needs to be disjoint. This is what this condition is saying. The chosen subarray, like first time if you choose the index I to j, the next time you have to choose something except I to j. Okay. So the chosen subarray needs to be disjoint and you need to convert this. Okay. And then the chosen substrings can be identical also. Matlab, sorry, this not this. This you can convert into this, and then this you can convert into another string. That is possible. But then it cannot be that this is partially covered by another substring that you are choosing the next time. So partial matches is not possible, which makes this problem solvable. So this was a very hard problem. Okay, this was a very hard problem only because this condition is given. Only because this condition is given are we able to solve this problem. So I was thinking, itna hard problem kyun de diya? Right? Then it would have become a BFS, standard BFS. You couldn't have done anything optimal. Just because this one line is written, we are able to solve this problem. How? Why? Right? It is saying that first of all, I can choose the same subarray multiple times, which makes sense, which allows us to do these kind of things, right? X, Y, Z. Even if there is a direct edge, I can choose X plus Y instead of Z. That is possible, right? So this is the first thing that you realize, that same substring can be chosen multiple times, which means the Floyd-Wasserwaller logic still remains intact. The second thing that is given is, after converting a substring, you cannot choose partial substring from that portion to convert another subarray, which means the chosen subarrays are being disjoint, which means if there is an original string like this and there is a target string like this, there will be some conversion like this to this, then some conversion like this to this, then some conversion like to this, and so on. It will never be like कि पहले इसको convert किया to partially match this much and then convert this much to partially, then convert this one to match this all. It will never happen this way. It will always be disjoint portions. Is this part making sense to all of you? That there will be disjoint portions that will be converted to the new counterpart in the other array. Is this making sense to all of you? There is another condition given, that original I, okay, original, and this is this, right? Okay, makes sense. Okay, this is what exactly needs to be done over here. So as soon as you read this problem, now this is a hard problem, obviously. This becomes problem of then a DP. So it's a Floyd-Warshall plus DP. Okay. So there is this, you should have seen this idea before, that when you have to break an array into subarrays, right, such that each subarray needs to be converted or used as cost, you think about the first element. कि भाई ये first element का क्या होगा? What will happen to this first element? Which subarray will it be part of, or it will be not converted? If you see this array and the target array, source array or the target array, think about the first character. Two things that can happen is it will stay intact, you will not do any changes on this, or you will choose a subarray like this, something like this, which will convert. Okay? So when you have this, let's call this dp of I, from ith index till n, what is the cost to convert this much into the other one? It is something that we'll calculate. The way to calculate is either if I is already correct, then you can skip it. If it is same, then skip dp of I plus 1. If already match, or you will choose some j till which cost of converting I to j to this part plus dp of j plus 1 to convert this rest into this thing. This is what we will use as a dp alongside the Floyd-Warshall. So this is a very standard pattern. Okay, this is a form 2 dp. I don't know how many of you have seen dp ka playlist on my YouTube. So this kind of problems are form 2 problems, which is ending at this or starting at this. You can use also ending wala ki what is 0 to I ko convert karne mein kitna lagega, what will be the cost of that, right? You see the last character in that case and you choose a subarray like this. So either way it's possible. But then dp of I basically says ki I to n convert करने में what will be the cost to convert it into the target वाला thing? You look at the first character always. The transitions of such things is always at the first character. You look at how does this match to this? Either it's already matched. In that case, I can just skip it. Or I can possibly look at some j such that I will choose this subarray to be converted to some other subarray, which will obviously be the target array. And then rest will be independent problem, because the question tells me that I cannot choose a subarray that is overlapping. It has to be perfectly disjoint. Okay. So this is what the idea is all about. Next is, let's look at the problem again. So sorry saying that. Source length and target length. Interesting. So this part is fixed. कि अगर हमें, like, if we know to convert this into the other character, we know what is to be used. Cost length, original length. So original length is there is 100 different nodes, right? Graph में nodes क्या होंगे? These original nodes and the changed nodes. These are the nodes. So there are only 200 nodes in the graph, right? Where is to the power 10,000 coming from? So let's take this instance. That will help us. Okay. Or let's take this. Let's take this instance and try to look at how will we code this. Okay. Bogus. Okay. This is the source. This is the target. This is the original string. This is the chain string. This is the cost of that, right? Let's have a look at source equal to this, and this should be, I think, enough. Right. Let's look at how will this work. So that the nodes in the graph will be B, C, D, F, G, H, T, H, H, C, D, E, T, H, H is already there, G, H, H. These are the nodes. All the distinct strings that are over here, they will be the nodes. Now you are given that to convert from BCD to CDE, it costs you 1. To convert from FGH to THH, it costs you, FGH to THH, it costs you 3. To convert from THH to GHH, it costs you 5, right? So this is the graph that will be there. We can solve all pair shortest path on this. So every shortest path we will be able to find in a matrix, 200 cube sort of. Okay. And then we can go with this source and target. Yeah, A, B, C, D, E, F, G, H, A, C, D, E, E, G, H, H. I think I should write it properly. A, C, D, E, E, G, H, H. Okay. Now what we'll do is, we will see how to convert. A already matching. So DP of 1. DP of 1 will be B, C, D, C, D, E. This, so the J will be over here and this will match with this. So I can convert it over here. So to match this and convert it to this one, we can simply go ahead and use the cost from over here. It will take 1 cost to match. And then we have to match this much. DP of 1, 2, 3, 4. DP of 4. DP of 4 will be E matches already. So that will go to DP of 5. FGH to GHH will be, FGH to GHH will be, the shortest path is 8. So this part will cost 8. So 1 cost plus 8 cost equal to 9 cost. That is how we are solving this problem. The answer is should be 9. Did this make sense to all of you? Okay. This is exactly the logic that you have to use in this problem. There are two logics merged. One is Floyd-Warshall plus DP. Like this matching style, whenever you have to match two strings, it's usually the second form, DP second form. Looking at the first character, what happens to that? Okay. If the lengths can change, then you have to use the third form, which is वो edit distance वाला जो property होता है ना DP का, that is what you have to use. But then when the lengths are fixed and you are just doing character to character comparison, You generally use second form, which makes it fairly optimal. Clear, everyone? We'll learn these DPs. I think how will we match exactly in terms of code? There are many things that you can do. One is you can put it in map, like put these characters strings in map, and you can check is it present in the map or not. Obviously, since the lengths are 1000, the map checks will be 1000 logins, right? Is this the LCS form? No, this is LIS form. Ending at I, or this is I. Look at my DP playlist. This is form 2. Okay. LCS form is form 3 basically, which means you have to use that is multi-dimensional array. So there are 2 indexes moving in both strings. In this, there is like 1-to-1 correspondence. So it's just single array actually. So in terms of code, what I will do is I will do Floyd Warshall. So first I will maybe like number them uniquely in a map. Okay. This will be node number 1, node number 2, node number 3, node. So put them in map, compress this to get unique numbers. On that graph, run a Floyd Warshall. Straightforward n cube, 200 cube should be fine. Then you have source and target. So what I will do is for every I will start looping forward. And if it matches with something, I can go to the other match also. So you can optimize things further using tries and all. You can put things in try and then use it to do the match efficiently, but I think it's not required. That for every I, even if you loop and find the, like if you keep appending the string one by one, so there will be an O of n match that you do per increment. So what is the source length and target length? 1000. Already an n square DP, and then you need to match it efficiently. So I think we will have to use a try to optimize it. Can we do it faster? So DP of I, and there is like O of n transitions for it. So n square. So the DP will be n square. But then since we are matching strings, there is an O of n overhead. To match it faster, you can use try or hashing to do it faster. ठीक है कि ये string से match कर रहा है नहीं कर रहा है, you can use hashes to match them faster or use try, either of the two. That's what I think people would have used in this question. वही use किया होगा पक्के से solution में लोगों ने. Either hashing or try to make it optimized, the matching part. So DP of I states O of n transition. There is a separate J to choose. So n transitions, n states, n square. The formula is number of states into 1 plus number of transitions. Number of transitions is n, states is n, multiply it n square. So you basically go with n square DP, but then matching this with the other one also has a O of n cost, which you can optimize further using hashing or try. So that is something which will make it O of n square solution. O of n square plus O of 200 cube. This is what it will be. Plus log here and there. Word break. Yeah, exactly. So if you have solved word break problem, the exact same logic is used over here. Thanks for mentioning this. This is exactly the same logic as word break problem. This DP you can also see in word break problem. The same idea that you start from a particular index and see till J which word is it matching with, right? And then you break it there and use the rest of the DP. This is exact same logic as word break DP. Thanks for mentioning this. I couldn't relate it to one classical problem. So word break DP. Similar to that, form 2, but then a standard classical problem exists of the similar type, word break. Clear, everyone? So this is exactly how you do this. Let's, I think, quickly move to the other problem. Similar question in test, how good would it be good? Given a string, find the total sum of palindromic transformation cost of all substring of the string. The palindromic cost of transformation is defined as the minimum number of characters that needs to be changed so that it can be rearranged to a palindrome. The palindrome transformation is cost this. Yeah, it's possible to solve this. Basically, it uses bit manipulation to some degree. It is a bit manipulation question. It's a bit try question actually. Per bit, you have to actually calculate the contribution. 26 bits when you use this. This is a different problem. I think not today, Shubham, maybe some other class and some class end के बीच में discuss करेंगे, ठीक है? Yeah, this is, which company is this problem from? This is a good problem. Palindrome rearrangement moves to bit manipulation. Represent every character with bit. If you can rearrange, the XOR should have exactly 1 bit or 0 bit ons. That's the logic for this problem. Then you have to play with try or bit contribution. Acha, NK securities last year. Okay, HFT. Makes sense. Yeah, did you see this? Array, so I didn't say that I will skip it for sure. I said that there is these two transitions possible. Either you skip it if already there, or you also try this. From the I only you try this. This is both, max of both. I was generating the solution, that's why I skipped it immediately. But then in this case, you try both. If it matches, then this is possible and this is always possible. So you try both of them, always. Is that what you're asking, Shivam? I think that's what you meant, right? Yes, correct. So you try both, but this transition only if already match. This is possible only if it already matches. That's the thing. You try max of both. In this case, I was skipping it because I was just generating DP1, DP4, DP5. I was just going through the solution generation, right? How is it going to find the answer? That's why. So this is exactly how this will work. Next is, we look at how do we solve it further. I think questions are discussed. All the questions are discussed. Maybe we can look at how we might implement this problem. The rest should be good, I feel. Is it? Last wala ka implementation be difficult. Last wala is hard implementation. The previous problem that we looked at, but then I think this is more interesting implementation, which we can look at, and then can think about how we can do it. Separately, you know. So how would you implement such a problem? So you can actually solve it with DSU also, maintaining all values, but then I'll only maintain few values. Yeah, DFS DP, not really DP. I'll just like create a struct which will store the value to be sent back. You know? So what I'll do is I'll create a struct which will maintain the value for a subtree. Okay, because it will be super easy to maintain that. Okay. Let's try to implement this right away and then see how we might actually could have solved it in the first place. हाँ, so edges दिया हुआ है, cos दिया हुआ है, and then we'll have to find the possible value to merge, the best possible way to merge this. So struct subtree या फिर val लिख देता हूँ कुछ custom val, हमें जो भी चाहिए वो हम यहाँ maintain कर सकते हैं, right? So what I can maintain is if there is a 12 values will be very overkill. I'm thinking to optimize it because it will not be required in that way. थोड़ा केस वर्क कर लेते हैं हल्का सा कॉपी लाइक नोटबुक पे दैट व्हाट विल बी रेलेवेंट. ओके, सो 3 वैल्यू निकालना है. सो पॉजिटिव पॉजिटिव पॉजिटिव, इफ दे आर ऑल पॉजिटिव देन व्हाट डू वी मेंटेन? लार्जेस्ट positives. If there is 2 positive and 1 negative, right, in that case what do we maintain? This will be negative. So smallest and then smallest, right? So पॉजिटिव में हमें लार्जेस्ट भी चाहिए, स्मॉलेस्ट भी चाहिए फॉर श्योर, इसमें भी स्मॉलेस्ट चाहिए. एंड इफ देयर आर टू negatives, sorry, only one positive, and two negatives, then this will be positive. So we want largest, largest, largest. And then if there are all negatives, then we might want to find. So it is given in the problem, no? Okay. If the product is negative, place 0 coins. If the product is negative, then place 0 coins. So this will result into a negative number. So this is not possible. This is also not possible. So we will place 0 directly over there. So we only need largest positives, 3 largest positives maximum, and two largest negatives. 2 largest negatives. है ना, मतलब 2 absolute value wise largest, मतलब smallest negatives. So if we maintain 3 largest and 2 smallest, we can find out the value. If there are none, then we will just simply use 0. अच्छा, solved only for positive elements. No, ये case work important है. This case work is super important. If you miss this, then it will be wrong. This case will be important. Minus minus plus. No. So I will maintain 2 largest negative values and 3 largest positive values. That is enough to solve this problem, right? Because in all cases, rest cases, the answer will be negative. And in negative case, I know that if these are insufficient to build things, then there must have been some negative answer. So I can simply put 0 in that case, right? So I can just maintain 3 largest, 2 negative. So I will maintain that in my code. So let's go back to the code. Let's see how we might do it. 3 subval, integer, or I'm just being lazy. You can please maintain this in a please maintain this in a vector if possible, but then I'm just going to use multi-set. So it might be that I might need to add certain number to this set. Like this is a set maintained for the subtree, right? So what we'll do is void add like lix. I want to insert a number x. So in that case, I might want to multi-set positive, large positive numbers, multi-set negative numbers, right? So if I want to add negative, so positive and negative numbers both will be added over here. So if x is greater than equal to 0, then it's a positive number. So I will insert it into the positive. If pos.size is greater than 0, then I will just evict off the smallest wala thing. So pos.erase, pos.begin. I will just erase the smallest number. And it's a multi-set, so multiple different values of the same type can exist. Else, if you have negative number, then I will do the same thing, but I will just make x equal to x minus x. Matlab, in negative, the numbers are maintained in absolute sense, but I know that they are negative, so I can just maintain it that way. Then I can just copy paste this code. They are negative, but I'm just maintaining their absolute value. So they are now positive for me. Is greater than, sorry, this should be greater than 3. My mistake. I just want to maintain the 3 best and 2 smallest numbers. 2 smallest negative numbers. That's all that I will maintain. And yeah, that's pretty much what we will maintain for this node. And then we'll have to do a bunch of graph stuff, standard graph stuff. Hai na? So how will we write it? What is the input? वो देख लेता हूँ यार. I have forgotten how to write graph codes now. Zero indexed, cost mentioned to you. Okay. Okay. We need to maintain subtree size. Yeah, that will be part of graph. So I can maintain bunch of things over here. So let me explain what I will keep. Vector of int subtree size. I just maintain size. Okay. And then we can maintain a graph. We'll need to build a graph. So I'll just copy paste this. And then integer n. So n is equal to how many nodes are there? Where is it given? Achha, cost dot size. And they are 0 index, by the way. So if there are 5, so it will be 0 to less than 5. No, sorry, this should be end, my mistake. But no, this should be neg dot begin only. Any. So negatives may, since I'm reversing it, I'm not maintaining the largest, I'm not maintaining them in the negative sense. I know they are negative and then I'm inserting positive numbers only. So I'm removing the absolute value wala smallest number. So that is fine. Okay. N equal to this size dot resize. This is standard graph stuff. N graph dot resize and okay. And then we have to go through the edges for int I equal to 0, I is less than edges dot size I plus plus int A equal to edges of I of 0 int B equal to this, and then you have to insert it into the graph. Since we have resized, it should be safe. A dot pushback. I'm writing very naively right now. So I hope you are able to understand the code. Hey, this is exactly what we'll do to build the graph, and then the routing is at 0. So I don't think we need to build anything more. It should be good enough. And then we can do a DFS call. I think we'll write the rest as and when needed. So DFS will start from node number 0, routing is at 0. And then the parent for that will be -1. When you're writing DFS for tree, you have to maintain the answers for it. And we also need to build the answer array, no? An answer can be large, 3 numbers, so it can be long. Graph dot resize. Sorry. These things needs to be resized also. Answer dot resize and so subtree. So this is what I will return from every subtree whenever I kind of do the DFS. Integer. So for every child, when I call it, I'll return its whole subtree ka pura jo top 5 values, and I will merge it into the parent wala thing. So subtree DFS node. Okay. So so for this particular node, I will build the subtree val temporary for this node. Temp dot add the value of the current node. I feel I was given this cost, no? So I have to pass this cost also alongside things because that will be relevant. Since I'm passing by reference, it will be order 1 pass. So cost of the NN will be inserted. Obviously, that is possible. And over here, I'll also build an answer, get answer. If these are the relevant numbers, get me the answer. So this you can implement. Then I will insert this cost, and then for auto, just drawing part हटाने दो यार, typing ठीक से नहीं हो पा रहा है. Auto V in G of NN, if V is not equal to V, then it's a neighbor, it's a child that we have right now. So what we'll do is we'll do subtree of the child is equal to DFS of the child, and its parent will be the current node, and we pass the same cost array. And then for I can just go through the positives and negatives of this child. For auto V in positives child का जो positives है उसमें I will iterate and I'll just insert them into the current node's temp dot add P. I'll also go through the negatives. Mind it, they are negative, so I'll have to make it negative and then add it to the current. So this is exactly what we'll do in this case. And once all the nodes are merged, I can calculate the answer for this node. I'm not sure if I need to add this node into the subtree also. If the answer doesn't match, I'll change it. I'll just have to move this down. Answer of the current node is equal to temp, this node ka jo temp hai, dot get answer. get answer, and then return the current node stem. This is all I need to do. This is exactly what will be the code for this, I feel. And then get answer, you'll have to implement. Acha, if pos dot size is equal to 3, then I can go through the 3 elements and multiply them. So LLI answer equal to 0 for auto v in pos. Is there 0 possibility? No, 0 is not possible in the question if I remember correctly. That's helpful. Answer multiply equal to, not answer, LLI temp equal to 1, answer equal to 0. Answer temp multiplied by equal to this particular value. 3 values we have multiplied. Answer equal to max of what is the max of temp? Answer comma temp. Okay, so this is exactly what we'll do over here. And then if possibly we have pos dot size is greater than 1, at least greater than equal to 1. If we have one positive number and we have at least 2 negative numbers, if neg dot size is greater than equal to 2, then we will bring the best 2 negative numbers and the best positive largest number, and then we'll get them multiplied. Okay, so the way I'll do it is temp equal to 1 so negative is greater than equal to 2 and the maximum size we maintained was 2. So I can just go through all negative numbers and multiply. And for positive, I just need the largest number. So I can just find out temp multiplied by equal to value at the last end iterator minus, right? So this is going to be positive dot reverse begin. Value at reverse begin should be enough. Okay, so this is exactly what we can use over here, and this should be good enough, I feel, for finding the maximum return answer. If none of these two cases hit, that means there were some other things that were happening, but these two were not possible, so the answer should be 0, so it will be returned. Let's try to run, see क्या क्या गलती किया हमने. Compiler error. Silly mistakes, let's correct them up. Temp 1 should be over here, colon should be over here. What more? Sorry, these are my, like, when I am trying to show you, I have to make things more cleaner. That's why I sometimes change the pattern, but I always name my things graphs, so it is a habit, basically. Why is it giving me one line at a time? सारे error एक साथ दो भाई. Acha, vector of long needs to be returned. So return answer, I feel that's what we need to return, isn't it? Oh, subtree size, we have to also do that thing, no? The subtree size, if it is less than 3, place 1 coins. So that is happening correctly. So these are working fine. If subtree size is less than 0, less than 3, so we can maintain the size also very simply. Size of nn is equal to 1. Every time you do DFS, you also do size of nn plus equals to size of v. And then if size of nn, give me like answer. Last okay. So size of nn is less than, yeah. Sorry for the interruption. Multiple interruptions यार. पापा एक पेमेंट कर रहे हैं, वो प्रोसेस नहीं हो गया सॉल्व एक बार में. ऐसे सॉल्व करना होता है कंपटीशन में. सॉल्व दिस वे. क्लियर? डू यू वांट द कोड? This is the code for all of you, which you can refer to in this case. Should be good enough to understand everything that we have talked about. Okay. Chalo, that will be all. Did you find today's session fruitful? Nice. Chalo, okay. We'll keep continue doing this every Sunday. No matter what happens, 4 o'clock, this is going to be there every week. One help I would love to get from you guys is to let few more people know about it, those who are giving it seriously, so that even they can join, because I feel this will help more people as they kind of learn through these things. So if you are in any competitive programming group or DSA group who are like not obviously very, very beginner, like people who are a little serious, they can kind of also join. So just send it in those groups so that more people can get to know about this. It will be a very big help to me. Okay. That will be all for today's kind of video. Thanks for kind of joining in video live session.